Welcome to this explainer. So, if you're standing right at the threshold of your civil engineering career, looking out at a skyline of steel and concrete, you might be wondering, how do academic theories actually translate into the physical reality of these massive, towering skyscrapers? Like, how do we take 2D lines on a blueprint and turn them into the precise, interlocking skeletons of modern buildings? Well, today we're unpacking the source material that answers exactly that. We're talking about mastering what is, frankly, an absolute non-negotiable superpower for modern site engineers and freshers alike. We're talking about the bar bending schedule. Now, if you ask industry veterans, project managers, or lead structural designers, they'll all eventually point you toward one critical question. What is the single most vital competency for a modern site engineer? You might instantly think, oh, it's got to be advanced structural analysis software, or maybe a super deep understanding of soil mechanics. And hey, while those are incredibly important, no doubt about it, for the ambitious civil engineering students tuning in right now, there is a much more immediate, high-stakes skill required the literal second your boots hit the dirt of an active site. Okay, let's dive right into this. The answer? The bar bending schedule, or BBS. It is the foundational, practical competency for estimating and executing steel reinforcement in modern construction. Think of it like this. It's the ultimate translation layer between the structural engineer's dream and the construction worker's reality. It's this comprehensive list that dictates exactly how every single piece of reinforcing steel has to be cut, bent, and placed. And mastering this, it's the ultimate prerequisite for surviving and thriving on a busy site. Section 1. The ultimate engineering prerequisite. Essential site readiness. We need to establish right out of the gate that BBS is the essential gateway skill for any fresher entering a construction environment. This is all about moving from academic theory to active construction. You know, in the classroom, you learn how steel behaves under tension, right? But on the site, you have a literal mountain of raw rebar and a notoriously strict deadline. The source material highlights that knowing how to prepare a bar bending schedule is what bridges that massive gap. Without mastering this specific skill, you're simply not ready for the intense, fast-paced reality of field execution. It's the stark difference between knowing what a building is and actually knowing how to build it. Moving on to Section 2, abandoning outdated legacy systems, or basically why the old ways fail. To understand the sheer power of modern BBS, we have to take a quick look at the history of estimation. Historically, the entire construction field relied heavily on Professor B.N. Dutta's legacy guidelines to estimate steel for various building components, and honestly, for a long time, that was the absolute gold standard. However, the source data insists that civil engineers today absolutely must abandon these historical frameworks in favor of modern BBS estimation. Why? Well, because the structures we build today are vastly more complex. Relying on those older guidelines in today's high-tech environment is just considered completely backdated. Here is the exact point of failure for those legacy systems. They provide entirely inaccurate values when multiple reinforcing bars are used in a single structural member. In the past, reinforcement setups were a lot simpler. But today, a single beam might be packed with a highly complex, tight matrix of primary bars, secondary bars, stirrups, and spacer bars. The old rules of thumb simply failed to account for the mathematical realities of these incredibly congested modern setups. Our sources are definitive on this, stating that modern BBS techniques make the entire process of estimating steel significantly easier and substantially more accurate than legacy methods. And let's be real, when you're dealing with thousands of tons of steel, substantially more accurate means saving massive amounts of money, preventing critical structural flaws, and actually keeping a project on schedule. Modern BBS is the ultimate solution you've got to master for true precision. All right, Section 3, mastering core structural components, progressing from basics to specifics. Because you don't just learn BBS as one single concept and suddenly know how to build a city, right? You have to systematically progress. This progression requires developing very specific skills for 4 absolute critical components: beams, columns, slabs, and footings. Each of these structural elements behaves totally differently under load, and therefore the steel inside them is configured differently. The way you calculate the continuous bottom reinforcement in a slab is a whole different ballgame from calculating the ties in a vertical column. These 4 components form the structural bedrock of literally any project, and you need a specialized mental framework for each and every one of them. So, a crucial takeaway here is understanding the difference between the overarching system and the microscopic math. In today's explainer, we are purposely avoiding the granular math. things like exact cutting lengths, specific concrete cover standards, or precise bend deductions. Instead, we are focusing on what you absolutely must master first: the modern methodology, the precision, and the estimation techniques themselves. Grasping this overarching modern methodology across those core components is what guarantees your estimation techniques are fundamentally sound before you ever punch a single number into a calculator. Which brings us to Section 4, Scaling to Megastructures, the extreme future of construction. Once you have that methodology locked in, you're ready to tackle the contemporary landscape. Listen, today's civil engineers aren't just building two-story suburban office parks. They are regularly tasked with mega-scale projects that demand absolute, unflinching mastery of modern BBS. Managing this kind of extreme structural scale requires pairing your BBS knowledge with advanced software and heavy equipment. The scheduling and estimation have to be totally flawless because at this scale, a single miscalculation turns into a compounding disaster on the job site. 150-plus floors. I mean, just think about that for a second. We are talking about contemporary high-rise buildings pushing higher into the sky than ever before. When you're pouring concrete and placing steel 150 floors up in the air, dealing with massive wind loads, immense gravity loads, and incredibly tight logistical constraints, your bar bending schedule isn't just a spreadsheet. It's the vital lifeline that ensures the right piece of steel arrives at the exact right time, cut to the exact millimeter. It all loops back to this core truth from our sources. Mastering modern BBS is a critical skill that enables engineers to successfully manage, estimate, and execute steel reinforcement on these highly complex, mega-scale structures. Your ability to actually execute at a massive scale is directly, inextricably linked to your mastery of these modern BBS methodologies. It's essentially the silent engine driving the modern skyline. So that leaves us with one massive, provocative question to chew on. Are your estimation skills actually ready for the modern skyline? We've covered why you have to move past legacy systems, the absolute necessity of mastering those core components, and the incredible, jaw-dropping scale that modern methodologies allow us to reach. But the next step? Well, that's entirely up to you. It's time to dive into that granular math, the bend deductions, and the complex drawing readings on your own to ensure that when you step onto that site, you are truly ready to build the future. Thanks so much for joining me for this explainer, and keep building your knowledge.